Yes, my dear students of 9th standard, nowadays we are discussing about periodic classification of elements, Unit 12, in your science book, which is a chemistry part. Already we have started. We learned about the early concepts of classification of elements. The first one, Dauber-Inner triads. Dauber-Inner classify the elements in the ascending order of atomic mass. Ascending order of atomic mass. 3 elements in a group. So that's why it is called the Dauber-Inner triads. Next one, Newland law of octaves. The Newland law of octaves, John Newland arranged 56 known elements, the increasing order of their atomic mass. So he grouped 8 by 8, 8 elements in a group. That's why this way of classification is called Newland's law of octaves. The next one, mentally periodic classification. Mentally arranged element in the increasing order of atomic mass. So the physical and chemical properties of elements are the periodic functions of their atomic mass. So he arranged 56 elements known at that time, and there are features of mentally periodic table because he only paved the way for the modern periodic table. He classified vertical columns, horizontal rows. Vertical columns are groups, horizontal rows are periods. Also, he arranged elements in a particular column having similar properties. And based on the mentally periodic table, mostly in 1913 classified modern periodic table. Based on the X-ray diffraction of experiment, he proved that the properties of elements depends on the atomic number, not atomic mass. So he arranged elements in the increasing order of their atomic number. So the basis of modern periodic table is atomic number, not atomic mass. Then he also classified the elements in the form of periods and groups based on mentally periodic table, and he grouped different families, alkali metals, alkaline earth metals, like that. Up to that already we learn. Now we are going to learn about 12.2.3, classification of elements into blocks. Classification of elements into blocks. So we know that electrons in an atom are accommodated in shells around the nucleus. Each shell consists of one or more subshells in which the electrons are distributed in a certain manner. So already we learned in the previous classes. So in an atom, protons and neutrons are located in the nucleus at the center. Protons and neutrons are concentrated in the nucleus, and the electrons revolve around the nucleus. And we used to say the electronic configuration is nothing but the distribution of electrons and the different atomic orbitals. And also we learned about the primary shells, K, L, M, N, O, like that we already learned. So these primary shells are used to locate the electrons based on the formula of 2n squared. We already know 2n squared formula is used to distribute the electrons in the orbital. But nowadays, see, we are going to study that not only primary shells, there are subshells also there. So actually electrons are distributed in the subshell. So each primary shell may have one or two subshells. So there are 4 subshells. S, P, D and F. We have to write these shells in small letter. K, L, M, N, that we have to write in capital letter. So each shell consists of one or more subshell. So electrons are distributed in subshells. Actually, there are 4 subshell S, P, D, F. So S subshell can have maximum 2 electron, P subshell can have 6 electron, D subshell can have 10 electron, F subshell can have 14 electron. So based on the arrangement of electrons in subshells, the elements of periodic classification also classified into 4 blocks. So based on the arrangement of electrons in the different subshells, periodic classification also classified into 4 blocks: S block, P block, D block and the F block. S block, P block, D block and the F block. So first we are going to learn about S block elements. So S block, which is going to define that group 1 and group 2 elements in the group 1 and group 2. So already you know what are called groups. Groups are nothing but the element present in the vertical columns of the periodic table. Vertical columns mean top to bottom. Top to bottom. There are totally 18 groups in the modern periodic table. 18 groups. So group 1 and 2 are in the S block. So S block contain group 1 and group 2 elements. So group 1 elements are called alkali metals. Group 2 elements are called alkaline earth metal. Alkali metal, alkaline earth metal. So except hydrogen. Hydrogen is gaseous one, lightest element because of their atomic number. Atomic number is 1. So it always located in the first position in the periodic table. Then these alkali metals like lithium, sodium, potassium, rubidium. So these metals react with water and give highly alkaline or basic natured solution. Basic natured. What is meant by alkali? Basic. Bases means which are going to turn red litmus to blue, which change red litmus to blue. This is an indication to test the nature of the solution. When the solution turn blue litmus to red, we can confirm the solution is acidic in nature. But these metals, when react with the water, they give basic natured solution which turn red litmus to blue. So they are bases or alkali metals. Alkali means bases which are readily soluble, readily dissolve in water. So the group 1 are called alkali metals, which is in S block. Also in the group 2, alkaline earth metal, this also in the S block. So alkaline earth metal, they combine with the oxygen and give oxides. They react with the oxygen. For example, see in the periodic table it is given, see second column, second group, beryllium, magnesium, calcium, strontium, barium, radium. So these group 2 elements which combine with the oxygen and give their oxides, metallic oxide. For example, magnesium burn in presence of oxygen and give magnesium oxide. So this magnesium oxide is basic in nature, and this magnesium oxide, when dissolved in water, going to give alkaline solution, magnesium hydroxide. Similarly, calcium oxide, calcium hydroxide. So these metallic oxides of group 2 are naturally basic in nature, and when these metallic oxide dissolve in water, they give basic natured or alkaline solution. Similar to group 1, this alkali natured solution also turn red litmus to blue because they are basic, they are alkali. So these group 1 and group 2 elements, lithium, sodium, potassium, rubidium, cesium, francium in group 1. In group 2, beryllium, magnesium, calcium, strontium, radium, and barium and radium. So these group 1, group 2 are in the S block, in the S block elements. Then next one, see P block. P block, these elements are in group 13 to 18. So group 1 are left extreme. Group that is S block are left extreme. S block elements are left extreme, that is group 1, group 2. P block elements are, that is right extreme, that is 13 to 18. Group 13 to 18. They are called representative elements. Representative elements. For example, they contain boron, carbon, nitrogen, oxygen, fluorine, and neon, except helium. So they are also called a representative element. The P block is home to biggest variety of elements, and is the only block that contain all the three types of elements, because this 13 to 18 P block elements consist of metal, non-metal, and semi-metals, metalloids. So all these elements are in the P block. For example, see aluminium, gallium, indium. So they are all metals. And carbon, nitrogen, phosphorus, sulfur, non-metal. Silicon, germanium, arsenic, antimony, tellurium. So they are all semi-metal. So also rare gas also, sir. So all the variety of elements in the P block. P block is metal, non-metal, metalloid, gases. All these are in the P block. P block. Then next one, see D block elements. D block, it includes group 13 to 12, 3 to 12. D block elements include group 3 to 12. 3 to 12, it is intermediate between S block and P block. That is 1 to are S block, 13 to 18 are P block, and between 3 to 12 are D block elements. So you have to understand clearly that S block are group 1 and 2. S block are group 1 and 2. Then P block group 13 to 18. Then in between S block and P block group 3 to 12. Group 3 to 12. And these elements are in the D block. D block elements. And they are found in the center of the periodic table. That is in between S block and B block. So similarly, their properties also intermediate to S block and P block. Their properties also intermediate between S block and B block. That's why they are also called transition elements. Transition elements. When you refer the periodic table, see group 3, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So these are the first elements in the group 3, 4, 5 to 12. And below that there are elements. So these elements are intermediate between S block and B block. So there are D block element, and their properties also intermediate between S block and P block. So they are also called transition elements. Transition elements. The next group F block. F block elements, it includes 14 elements after lanthanum. Atomic number 56 called lanthanides. And after actinium, 14 elements, atomic number 18 are called actinides. They are placed actually at the bottom of the periodic table. They are also called inner transition elements. So these elements are actually should accommodate in the intermediate in the transition group in the D block 57 to 71 and the 89 to and 3. When you see the periodic table, you can understand. So that pink color 57 to 71, lanthanum to lutetium. So 14 elements. So these 14 elements should be placed here inside this periodic table. Then also 89 to 103 actinium to lawrencium, and these 14 elements also should be located here, but mostly kept these elements below the modern periodic table, because lanthanum to lutetium 14 elements, actinium to lawrencium 14 element having similarity in their properties, similar chemical properties. So these 14 elements are kept or arranged below the long form of periodic table, below the long form of periodic table. And so these elements are called lanthanides and actinides. Lanthanides and actinides. So lanthanides are lanthanum to lutetium, lanthanum to lutetium, and the actinides are actinium to lawrencium, actinium to lawrencium. So here so for example lanthanum, cerium and presidium, like that, actinium, thorium, so up to lutetium and lawrencium. So these 14 elements are kept below the modern periodic table because of their similar properties. So they are also called inner transition elements because they should be included in the transition group, and that is intermediate group of D block between 3 to 12. So that's why they are called inner transition elements. Inner transition element. So my dear students, so far we learned about the different classification of element, different blocks based on the subshell. There are 4 subshell: S, P, D, F, and based on that elements are classified into S block. Group 1 and 2 are S block, alkaline earth metal. And group next to see P blocks are 13 to 18, 13 to 18. So these elements are having biggest variety, having metal, non-metal, metalloids and gases. And D block elements are the intermediate between S block and P block, and F block elements are lanthanides and actinides. So you have to go through the different classification of element based on subshell, and you have to get the clear knowledge of about the uh, different blocks: S block, P block, D block, and F block. So prepare well. Thank you. God bless you.